Okay. Hello students. Now today we are going to start the other types of the matrices. First we have start 6 types of matrices. Now we are going to start the next one, negative matrix. A matrix minus A is said to be negative of a matrix A if sign of all the entries of A is changed. Suppose we have a matrix A 3 1 0 1 7 9. We can see there the negative of a matrix minus a sign of all the entries are changed. 3 change into minus 3, 1 change into minus 1, 0 remains same. 1 change into minus 1, 7 change into minus 7 and 9 into minus 9. So this is called the negative of a matrix. This is the matrix A and negative A minus A is the negative of this matrix A. See the other one, if B is equal to minus 1, 0, 7, minus 3, then negative of matrix B minus B is equal to 1, 0, 7 and 3. Minus 7 and 3. So the sign of the all entries are changed. 1 minus 1 change into 1, or we can also say that sign is changed multiplied by minus. All the entries multiply by minus 1. So 1 change into minus 1, zeros remain same, 7 change into minus 7 and minus 3 change into plus 3. So this is the matrix, negative matrix of a matrix B. Same here, we can say that this matrix is the negative of this matrix. Next one, see that skew symmetric matrix last time we have studied two matrices types, transpose of matrix and negative matrix. Now we can study them together. If the transpose of a matrix A is equal to the matrix A, then it is said to be a symmetric matrix. For example, we have a matrix one, 7, 3, 7, 2, 5, 3, 5, 8. Then we can see there A transpose is equal to, as rows change into columns and columns change into row. So first row change into first column 1, 7 and 3. Next column 7, 2 and 5. And the third one 3, 5 and 8. Look at their first entry, 1 is equal to 1, 7 is equal to 7, 3 is equal to 3 and all the entries are same. All the entries of matrix A is equal to the all entries of A transpose. So we can say that A transpose is equal to A. This matrix is called symmetric matrix. If by taking its transpose it is equal to the similar matrix which transpose is taken. The next type of matrix is skew-symmetric matrix. In skew-symmetric matrix, if the negative of a matrix, if the transpose of a matrix B is equal to the negative of the matrix B, then it is called skew-symmetric matrix. For example, we have a matrix B is equal to 1, 3, 6, minus 3, 2, for example, B is equal to 0, minus 2, 7, 2, 0, minus 3, minus 7, 3 and 0. In case of the transpose of matrix B, B transpose is equal to 0, minus 2, 7, 2, 0, minus 3 and minus 7, 3 and 0. We can see there B transpose is equal to minus B, as we can find the negative of matrix B. We can see there 0, 2, minus 7, minus 2, 0, 3 and 7, minus 3, 0. So minus B and B transpose are equal. That's why it is called skew-symmetric matrix. This is the example of a skew-symmetric matrix. See the next one, diagonal matrix. A matrix is said to be a diagonal matrix if at least one entry in its diagonal elements is non-zero and all the other elements except diagonal elements are zero. For example, M is equal to 0, 0, 0, 0, 1, 0, 0, 0, 7. These are the diagonal elements. In this matrix, at least one of the diagonal elements is non-zero and all other elements are zero. For example, see the next one. N is equal to 7 0 0 0 3 0 0 0 5. You can see there diagonal elements are non-zero. At least one diagonal element is non-zero, but there are all the three elements are non-zero. So this is also a diagonal matrix. For example, see the next one. O is equal to 0 0 0 0 5 0 0 0 and 0. So only one element in its diagonal 5 is non-zero. All the other elements except this element are 0. So this is also our diagonal matrix. The next one is scalar matrix. In scalar matrix, scalar matrix is our diagonal matrix. Our diagonal matrix whose all the entries of diagonal elements, all the entries of diagonals are same, is called diagonal matrix. For example, A is equal to K0 0 0 K0 0 0 and K. We can see that only the diagonal elements are the K. They are the same elements. All the three elements are the same, and all elements except the diagonal elements are 0. So it is our diagonal matrix whose all the entries of diagonal are same is called a scalar matrix. It is a scalar matrix whose all the diagonal elements are same, but all except diagonal elements are 0. First it is a diagonal matrix, and then all the entries of diagonal elements are same. So this is called the diagonal scalar matrix. The next type of the matrix, the last one, identity matrix. A diagonal matrix are a scalar matrix. We can use their scalar matrix whose all diagonal elements are 1 is called identity matrix. For example, I is equal to 1 0 0 0 1 0 0 0 1. So all the diagonal elements are 1, and it is a scalar matrix whose all the diagonal elements are same and other all elements are 0. For example, I is equal to 1 0 0 1. Also in this matrix, diagonal elements are 1 and all the other elements are 0, so it is called identity matrix.